We work on epithelial cells sheets. So basically, your skin is all epithelium, but every organ in your body is coated by a similar, very simple epithelium that's like skin for each organ. And because of that, it does most of the function of the organs, but it also creates a protective barrier for each organ. And so it's really important that that barrier is maintained, otherwise you could have infections. Yet, at the same time, these cells are turning over at very high rates by cell death and cell division. And nobody really understood what causes those rates of cell death and the rates of cell division, like what causes those two things to happen. They've kind of studied in separate labs. And we thought it's actually really much more important to understand how they're happening naturally and how those two processes are linked together, because if you had too much cell death and not enough cell division, you'd get breaches of the barrier and inflammation. And on the other hand, if you have too many cells dividing and not enough that are dying, then you could form tumors. And that's what happens in cancer, is that, most cancers form in simple epithelia like this, like 90% of cancers form in these kind of epithelia. So we were really interested in these two processes and how they were linked, and what we found is that it's just very simple, and it's down to mechanics. Basically, if there's not enough cells and the cells are under stretch, they activate cells to divide very rapidly within only an hour. And if they're under too much crowding because there's too many cells, then they activate some cells to die through this process that we discovered called extrusion. And extrusion is what mostly my lab works on, because this is the process we've defined that really causes most epithelial cell death. I think potentially I have some ADD and I can't focus on things. So initially I went to work on a lab that works on wound healing, and I was making these wounds, and my PI was really mad at me because they weren't closing the way he was wanting them to close. But what I noticed in the background was that there were all these wounds that I hadn't made. So I was looking at the wounds that were closing, but I couldn't focus on that because there were all these little tiny wounds surrounding it that I hadn't made. And what I found was that those were cells that were fated to die that were making these tiny wounds, and those were the extrusions. And so from there my PI wasn't interested in this, and so I just went independently, and I had my own funding. I think it was when I was in, when I was an undergraduate, it wasn't a career to be a scientist. It was just something that sounded sort of like fairyland, or it wasn't a job description very much. And I just remember sitting in a cell biology class and listening to these really interesting stories about how horseshoe crab sperm can polymerize these, extensions of a cause of fertilization. And I was just blown away, and I thought, this is so cool. And the guy who's done that work, I really followed a lot of his work. It was really amazing. But then I went on to graduate school, and I went to UCSF, and they're really strong for cell biology. So it was just like there was a whole bunch of people I could apply to, and I had a really great time. So I guess it was just kind of a little spark, and then it ignited more. Mainly find, when you're finding your lab and when you're finding what kind of project you work on, find something that's really interesting to you that you can't wait to get up in the morning and run into lab and do, because that can carry you through. You have to really own your project, right? And if you don't feel that excitement, then it's maybe time, in the same way that you fall in love with somebody, you should be falling in love with your project. So if you don't feel that excitement, I think it's time to switch. So I felt like I fell in love with this project with extrusion, but I was in an environment that was not very conducive for it, and it was like I didn't have any of the equipment that I needed to study it with, and so you just kind of have to be single-minded and follow that, and that also matters, like what environment you're in, but also your project. And so I think that's an important thing, but also don't get stressed out about if it doesn't work out. You can always switch. You should always know that you can always switch, and I think that alleviates a lot of the stress of the decision, so you're making calm, cool decisions about what you want to work on, and that it's really fun, because your 5 years in graduate school should just be really fun.